Hello, everybody. My name is Anil Kokaram. I am the head of discipline of the Department of Electronic and Electrical Engineering here at Trinity College, Dublin. And I'd like to tell you something about the Masters in Electronic Information Engineering. So, first of all, something about our department. It is the number one electronics engineering department in Ireland. Is in the top 150 in the world. The engineering school of which we are part um, is ranked in the top 100 worldwide. So this is the right place to be. The department is heavily associated with large research institutes, the ADAPT Institute in digital media and the Connect Institute in communications infrastructure and communications research. And that means our staff is sort of broadly divided into four discipline areas. We have digital communications, then we have electronic platforms, where we have a mixture between traditional hardware design and biomedical device design. And then we have digital signal processing and control engineering. And finally, somewhat related, music and media technology group. You could find a lot of information about these groups in the top left-hand corner if you look at those websites. The department is quite unusual for a department like this because there have been some significant relationships with high-profile companies over the years. And just to give you a couple of examples, twice Google have licensed intellectual property from the department. The most recent time in 2015 was the research work of Professor Frank Boland. So every time you try to listen to VR and spatialized audio or 360 video on YouTube, the underlying spatial audio software infrastructure is actually based on work that Frank Boland did in his group many years ago. Also very unusually for electronics engineering department, your MSc course coordinator, who is also a lecturer on the motion picture engineering module, actually won an Academy Award for work in motion estimation in cinema special effects. And that's a very strange thing for an electronics lecturer, and you might recognize the picture there. So this course really is something we developed over a number of years to address the realization that electronics now is really a mixture of algorithm design and hardware, and it covers a very broad area. The impact of recent developments in signal processing and machine learning could be felt everywhere right now. So in your phone, with the quality of the pictures from the camera, with the ready availability of speech synthesis modules in Alexa and Siri and so on, autonomous driverless cars, even entertainment and media, full of the fruits of a lot of years of research in electronics and information technology in general. But what is interesting is that this has sort of driven a renaissance in the consumer electronics industry, because all of these things rely increasingly on the design of low power, high performance computational devices in hardware, and also rely on the development of low power, high signal to noise ratio sensors. So our course is sort of geared for electronics engineers to get an appreciation of both of those domains with the relevant bias that you might like. And in a sense, we want to prepare our master's students to survive in the age of automation. And since 2017, The Economist has been running a number of really interesting articles on this, and no doubt you are aware about the buzzwords of the fourth industrial revolution and the impact of machine learning and so on. This course gives you both the hardware and software or algorithmic aspects. Now, for new course participants, there are a number of key things you want to know. First thing you want to know is what sort of jobs does this course prepare you for? So it certainly prepares you for jobs like these here on the left-hand side: speech recognition, video systems engineer, communication systems engineer. And I have a number of quotations from former students who've gotten jobs in the startup sector around the world, as well as in general information engineering around the world. And on the right-hand side, there are examples of where um, in Ireland, there are opportunities in these areas. Intel, Movidius, Xilinx, their R&D headquarters here in Dublin, recently acquired by AMD, so they are going to explode. Qualcomm made a major investment in R&D in Ireland quite recently. Of course, Google and some of our graduates actually work in YouTube. I myself spent 5 years working in YouTube, which has influenced how we design this course, in fact. Um, and then Huawei and so on. Since last year, we've had a number of donations from significant donations from companies, so that we are in a position to give bursaries worth about 3 to 5K to high quality applicants to our program. Now, the way we think of our program is that there is a sort of fundamentals of signal processing, machine learning, and probabilistic inference, and then a number of application areas built on top of that. So audio, video engineering, telecoms, digital communications, neural engineering, and bioelectronics, and also sort of computational hardware. The deep learning course is very significant. We were the first to launch a deep learning course for undergraduates actually in Ireland, and now offering it to the master's program. And the lecturer is Francois Pitié. You could have a look at his Google Scholar page, and you will find also linked to his GitHub page, and you could look at what the course content is in detail there. But it's about giving you, regardless of whether you do hardware or software, it's about giving you experience in the tools required to use deep learning in design, in any sort of quantitative design that you undertake as an engineer. So you'll get experience with Google Colab, Python, TensorFlow, all these things that make you be able to be functional in engineering for the use of deep learning in various applications. The course includes keynotes from a number of important industries, and previous keynotes came from Google, Intel, and Xilinx, because we have a good relationship with those companies. And that's a picture of the class sitting in one of the rooms in Google Dublin when the class was actually small enough to fit. And now it's much bigger, of course. This is an example of the module choices for next year. And I just point out that we have two hardware courses there in the area of sort of computational engineering, and the other courses are in the general area of digital communication, signal processing, and media engineering. I'll point out three new courses there: quantum computing, computational engineering with Python, and biomedical image processing, which will be options going forward for next year. And we're working on developing these right now. You must do a dissertation project, the research methods course, which tells you how to conduct scientific investigations, and the result is a 50-page dissertation. Then the module on deep learning, and then a number of other modules which mix comms and signal processing and media engineering. You could find out details of those courses here on our website, and this YouTube links to a small clip of me talking a little bit more about the course. These are some examples of 4 streams that you might be interested in: media, signal processing stream, communications, computational engineering, and cyber physical systems, which is the fancy word for embedded systems. So for a couple of years now, we're running optimization and control, and we will add self-organizing systems to that, and optical communications. Computational engineering is sort of about algorithmic design for things like speech recognition, video engineering, video coding, video streaming. And in ComStream, you're more on the networking and communications infrastructure side. The media engineering side is both speech and audio as well as motion picture engineering. Um, so something about your timeline now, you'll see that around now you should apply, expect to be called for about a 30-minute interview. I will be asking you to explain your capstone project and the ideas behind it to make sure that you have some idea of what it takes to do individual project work. You'll do a short coding question in MATLAB or C, and this is very important for us to understand your background. If you're accepted, then expect in summer of next year to get some preparatory tutorials in these areas, which will help us fit you to particular modules. You arrive in September next year, and then you meet your supervisor and start your MSc dissertation project from day one. You have 2 sets of examination periods at the end of semester 1 in December to January next year, and then in the end of April at the start of the summer period. Then you submit your dissertation in August, but we expect you to be working away at your project throughout the year. So here are some quotations from students, successful students from last year. And there's quite a lot of stuff here. You could pause this video right now and have a look yourself. But just to pull out some key points here, the one student is saying that he valued the mentoring system quite a lot. So there'll be 2 of you to 1 academic supervisor with an expert in that area. And it is really in this project that you get into details of the algorithms and systems that you are interested in to shape your career. Okay, and if you are interested in research, that is also an opportunity for you, of course. On the bottom left here, this student is talking about how we prepared him to do to appeal to particular industries, and he was really interested in video engineering, as it turns out, and he's now working in Tencent. On the right-hand side is a student who did a project in voice recognition, and now he's working exactly in voice recognition technology in a new startup in China. So the course has all the right elements. It's up to you to put the effort to succeed at these elements. So as you'd expect, the course is a mixture of lectures and assignments. Some courses are completely assignment-based, like motion picture engineering. Some are a mixture of final exam and assignments. We have strong connections with industry, so expect to see a significant number of keynotes, especially in the second semester. You must pass all our taught modules with an average of 50% and pass the research project to proceed to the degree, right? If you don't pass all the taught modules, then you don't go on to do the research project, and you may receive a diploma. Now, the research project is really important. It demands a significant effort. 50% of the credits for this course goes to that project. 40 credits for the project itself, and 5 credits for the research methods module. You'll write about 50 pages in your final report. So we need to know that you are committed to this program, and that means you've had significant experience in your capstone project to be able to make that next step to individual research to create more detailed dissertation on your own. So we do prefer students who have done an individual project report for their capstone project, but the interview actually is quite important for us to assess that. You will, of course, be assigned an individual professor as your supervisor, and there are 3 points in your progress: an interim report, a presentation, and a final dissertation. So just to give you some highlights of modules, and you can see this web page for more detailed information. I'll start off with motion picture engineering because I lecture that. It's about video processing, algorithm design for video streaming and cinema post-production, and it's very connected to industry and how research could lead to new industrial development. So up there you could see Paul Wilkins, who has visited twice before. He is a Google engineer who's worked on the new technologies in video codecs, which are now being used both by Google and Netflix. And at the bottom right, in a very small below the Netflix logo, there is Yanis Katsavounidis, who has been lecturing our students on developments in picture measurement and optimal transcoding for video streaming over a number of years now. A lot of the technologies that you will learn about in motion picture engineering are or have been used in cinema post-production and movies like these. So it's quite a popular course. In the course by Naomi Hart, Speech and Audio Engineering, you can have a look at her Google Scholar page. It's about the design of speech recognition algorithms, and there are a few snapshots of projects that she has offered in the past. For instance, investigating the effect of aging on speech recognition, because as you get older, your speech changes, and if you train a speech recognizer to recognize your voice at a particular age, it doesn't necessarily function the same way as you get older. Now, as I was saying before, we have a significant relationship with Science Foundation Ireland research centers, ADAPT and Connect. And Nicola Marchetti is a good example of one of our academics who's heavily involved in communications under the Connect Science Foundation Ireland Research Center. And he does a course in complex systems. And this year, for instance, he's taken on a master's student working on 6G for public health, and actually looking at the use of radio waves to detect coronavirus attached to walls using particular materials that are sensitive to the nature of the virus that's stuck to them and the nature of the radio wave. Very interesting proposition. Justin King is a new lecturer in hardware design, and he's offered a number of projects in device modeling with machine learning and simulating the behavior of low-level devices using software and more data-driven methods. Then we have Srijit Shankar. He is a new lecturer in hardware design and reconfigurable hardware, and he's done some interesting work on machine learning for chip designs, as well as hardware for autonomous driving and so on. And a couple of his students in the master's program have worked in these areas over the past years. Finally, if you come to our program, you could also take some modules from the music and media technology program. So if you are interested in using digital media to make music, a couple of these modules quite interesting. And one of the lecturers in our course, second from the right here in debates, was one of the first 5 people to upload and actually use 360 video and spatial audio to broadcast new sorts of recordings on YouTube. And you can see some of his work here if you look at NDebates' website. So there are a lot of other opportunities for career development during our program. Trinity Engineering School, as well as the Computer Science School, runs careers fairs at regular intervals. The keynotes that you get give you a picture of what the electronics industry is like. in Ireland. And of course, if you're interested in sports, a lot of sports here over the summer, football and cricket being just two. So finally then, couple of takeaways to remember. It's a 1-year full-time program, 90 credits, half of it is a research project, and that means you have to be pretty committed to that program to get to the end of it. You're the sort of person we are targeting is people who want to learn about the new developments in algorithm design and how they influence the latest in a range of technologies in electronic information engineering, um, both from the hardware and from the algorithm software perspective. Okay, thanks for listening. I hope you found that interesting. Please go to our website to find out more information, and I look forward to seeing your application to this program.